Okay, in this video, I want to explain why this proposition here is true. All right, so in this case, our domain is the integers 0 plus or minus 1 plus or minus 2 plus or minus 3 on to infinity. So the integers. Okay, and the statement is saying that no matter what x you pick from the integers, if x is bigger than 1, then x squared is bigger than x. All right, so let's first look at an x that is in fact bigger than 1. All right, so just as an example now, that just an example is not enough to prove a statement, but we're not proving the statement here. We're just trying to determine if it's true or false. Okay, so we can just look at a few examples. Let's look at x equals 2. So then the question is 2 bigger than 1? Yes. Two is bigger than 1, so we satisfy that. And now, is 2 squared bigger than 2? 2 squared is 4, is bigger than 2, so we satisfy that. So in fact, we see that it's true. All right, and we can go through the same sort of idea with examples for, let's see, x equals 3. It's true that 3 is bigger than 1, and it's also true that 3 squared is bigger than 3. 9 is bigger than 3. So we see that in that case, for that x, it is true that if x is bigger than 1, then x squared is bigger than x. So now what we want to do is we want to think about, okay, so now we can see that if we pick an x that's bigger than 1, then in fact the contract is upheld. That if x is actually bigger than 1, then x squared is bigger than x. Okay, so now so where students often run into trouble with these types of problems, and the reason why students often think that this is in fact false when it is true, is they say something like, well, let's consider 0. Okay, well, what about x equals 0? And students will say, well, look, it's not true. It's false that 0 squared is greater than 0. And it's true. This is false. But, and here's the key point, right? It's true that for x equals 0, 0 squared is bigger than 0 is false, right? Because 0 is not bigger than itself. 0 is equal to itself. So 0 squared bigger than 0 is false. That's absolutely correct. That's correct reasoning there. But that's not correct reasoning about the conditional statement. The key part here is that 0 is not bigger than 1, right? So we're false in this part here. And anytime we start with a false, the overall conditional statement is true. This is an instance when we see why conditionals have to be defined the way they are. It's the only way that makes logical sense.